Here I come. Oh, here I come.
Yes. Now it works. What? Hello, everyone, and welcome back to day 5 of me trying to develop an exploit for Squirrel. Last time we fixed the fakeObject primitive in the heap shaping. And one thing that I forgot was that we... No, 1 second. Okay. So one of the things that I forgot was that we had a list here, a checklist, and it really helped me to focus. And ever since I forgot that I have this checklist, I really just walking around in circles, thinking about what would be my next step, and then forgetting about the next step. And that's really non-productive. So let's set our goal for today. And also like retroactively add the previous one, which was fix heap shaping. And today we are going to craft an arbitrary read write. Read and write. So let's start off with a read. So yeah, last time when we fixed the heap shaping, we had this, we managed to craft this fake object of type string, and the length of it was really big. And it's really big because it's the result of a type confusion. Yeah, so we actually like reading this pointer at a certain offset, at the same offset of, you know what, let me just show you. Skew. What is this? What? SQ string. And how do you split with this? I installed a new plugin, like a Vim plugin. So say split. Yes. And now we want to open SQ. What was it? Print. It was a print. So it's a native closure, right? So SQ native closure. And this is the native closure object. So we are essentially confusing between those two objects. And the len property is at the same offset it's in the same offset of, where is it? Shared something. shared state, but it's not here. Oh, I know why. It's because probably in the what? GD. Okay, that's weird. What? Chainable objects. What? Let me. No. Maybe that's just an error because. 1 second. Include. SKU. What do you need to include? Squirrel. Maybe that will fix. It fixed some of the errors. Squirrel.h. Squirrel.h. Oh, I hate this. Anyway, we were here. XQ closure. You know what? Let's just search for it. Shared state. Shared state. Yeah, no found. That's weird. Anyway, I'll show you. Look, I saw this on GDB. And then share clear, and then break at SQ rocket. CPP. CPP at line 965. Okay. Oh shit. No. Wait. We need to put that. Okay. What? What's happening? Run. What? 967? That's not what we... Roget. SQ API. That's weird. 967. Okay, let me just pause the video because it's taking too long, and I will fix this, and then once I'll figure out what the problem is, I will continue and describe how I solved it, because I have a feeling this is going to take a while. Okay, I just re-downloaded the sources, and the issue was with the sources. So I just re-extracted all the sources from, like, I just re-downloaded it and extracted it, and yeah. And I also fixed the offset here because it was incorrect, because as long as we change lines in our exploit, the heap layout changes as well. So as we continue to develop the exploit, we will just need to fix every time the offset, unless we find another heap spray technique, which is like heap spray strategy that will be more consistent or predictable. So yeah, what I wanted to show you earlier was that we are confusing two types. The first one is string, which is the fake object that we crafted here, which is this one. And the other type is a closure. Now, that closure has fields, and one of them val, and then unval, and then p instance. No, I'm sorry, p native closure, and that native closure is print, because we ran the adderoff function on the print function. So we got the address of it, we put it here in the SQObj pointer, and in the type we set it to be a string. And it shares the same, like it shares, let me show you. This is how, I'll just copy it. And how can we do H split? No. Yes, okay. That is p native closure. Nope. P native closure, and that would be pString. pString. And what we see here is that I print the same address, but I treat it with a different type. Here we're looking at this address as a string, and here we are looking at this address as a native closure for what it really is. But in our script, every time we access fakeObj, the language engine will think that we are talking with a string object, like interacting with a string object. And the length field of that string object is at the same offset as the shared state. Yes, you see, like there's no way that the length of that string is that big. This is clearly a pointer. And once you look at the same address with a different interpretation, like with a different type, you can see why the length is so big. It is because it's not a real string. It's actually a native closure object that is being treated as a string because of us. We faked a fake object. So back to our task, which was to craft an arbitrary read. One of the things I thought about, like I think yesterday, was to if we want to craft an arbitrary read with what we have here, we can change this to an arbitrary address. And every time we call length, I think this is still a theory, but we will need to check that. Every time we call length, it will print the value of this address plus the relevant offset to get to this value, which is this offset length. Yeah. So you can see it. Let's go. Right. Oh, it's not offset. Offset 0x28. So that offset 0x28. Right. And if we look at the source code of like string length, sq string, register string lead. This is probably here. Format, strip, strip, split, escape, ends with. Yeah, that's not part of the string. How do you string? String. I want to see who touches that string. Oh, that string slice. get size. So perfect. Every time we're calling length in our like here, it will probably call the get size. Where is it? Get size. Memory SQ get size. And then raw. One. Why? Oh, because we did that. But we need to hope that it won't crash here, because sometimes it is. Huh. Okay. Print. Next. Next. Print type. Yes. Okay. NI. Yeah, you can see it's like the exact offset of 28. Just like we said, like here. And if we step over this and then inspect REX, we can see that address. Cool. Okay. So essentially every time, and this is going to be a little sneaky, arm read. So we subtract 28 because we want to, because every time we will call len, it will jump plus 28. So we subtract 28 and then we call len, which will add 28 and give us the value at that offset. And return. How do you say it? Like fakeObject now. fakeObject. Yeah. Now I'm wondering if we have access to buff. We can see read buff and print. And Nick. I think it has errors, but we'll see. This is 1. This is 2. Yes, it works. Very fucking nice. Okay. Okay. And if we want to read, I don't know, let's try to. Or okay. Right. Do this. And that. Now let's see. Integer and null. Oh, I'm sorry. It's not leak, it's off. And that's 1. Why didn't print anything? 2. That's weird. And now we have a sec file. Let me just see it. Build hack sq x.net. Index line does not exist. fakeObject. We have buff. Yeah, but if you do this with 1, leak print address. Just oh. That will work. There we go. Off. Okay. Now. Index line does not exist. Okay. Maybe the offset changed. Let me see. Shall we run? Oh, sorry. Run. And orbs. That's the offset. Yeah, that still works. Okay. Yeah, it works. So what's wrong? I don't understand. Archery. Okay. Continue. It's still like that. So you're doing raw get. You're going to get size. And you still get that. Man, I don't know. I don't know. But it works. So why would that? That's super weird. Armchair read. Index len does not exist. Oh no. Maybe. I know. I know. We can for okay then buff is 0x. How much is it? 0x 800, I think. Yeah. So we will no, not line buffers. IDX is 0 as long as IDX is less than line buff, then IDX plus plus, and just spray them. I don't care anymore. You don't have to be precise with this. Just 0x 10 bytes. You can spray the shit out of them. Yeah. Let's see. In fakeObject. Oh shit! I'm sorry. No, that's not. IDX 20. That's what you need to do. Cool. Now that is what I'm talking about. Let me see that. Yes, it's that address. Looks good. So we have an arbitrary read. I mean, that's pretty exciting. Let me see it in a loop. Let me see it in a loop. No, I want to do this like the other terminal. Oh. Yes, that's how I want. Build sq and then hex.not. And finger crossed. Come on. No. Why? Why? Oh, shit, no. As long as, like, oh, oh my god. It is smaller than, shit. That's awkward. Okay, now let's see if it works. Finger crossed. No, it's not gonna work. Leak. What's that? You know what? Just do it like 0x10. Okay, let's call it twice. Let's not be too greedy with 0x100. Let's call it twice. Still no, it doesn't work. Oh my god, that's disgusting. Okay, let's try it. Let's try it twice. Twice like that, and not twice in a loop. That works. Okay, and if you do like +8. 0x8 and 0x10. Now we need to pray. Oh, it just won't work. I don't understand why. Len buff is 0x80. Okay, can you read? Is this because we added 8? What if you read +8? Yeah, that's the issue. It's because we're adding. That's the issue. it's crashing. No. Okay, that works. We can add 8. That doesn't crash the fucking system. Yeah. Is this because, yeah. This should crash. New address. Okay, new address. Let me see that. That's like super weird. Why would that be a problem? It's just a number. Alright, let's see where it crashes. Continue. Dead beef. Oh. Okay. I can just... I forgot about the attributes. Sometimes the attributes are like... Now I feel stupid. Okay, now let's see. Just increase that. And clear. Now let's see it. Should work. No, it's not. Okay. Why? Get size t type. Return. Leave frame. Null. Rex. Okay, what if you just add 20, add 10? Pointer null. It's here. What is this? Let me see if it crashes. I fear that it crashes here or during the return. So let's see. Continue. Yes. It's That's super weird, you know. Run. Continue. Next 4. Okay, that's bad. That's not what we want. What? It's not. Huh. Run it again. Print O. And pString. It has a length of 2. Oh, that's okay. Because we are increasing it by 8. So we're no longer reading from here. We're reading from the next one. So it's here. So it works. It works. But something, it's return. So when you return, next. Yeah, it works. Okay, now we're doing like leave frame step. Inside the VM. And no, it wasn't here. It was in return or something. Return. Maybe it's trying to free free. Next. Finish. Yes. T all type. T no an all well. History. Yeah, it's here. The length is 2 and the next is that. So it causes a seg fault. This wasn't a good idea to extract information from the heap. Not a good idea. Release. That's where we are crashing. Pref counted. Release. It's like referencing the old value. Ref count. Okay, and we are calling this from return. Leave free. So that's release. Delete. Yeah, he's trying to free it. Yeah. Because we are leaving the method. So we can maybe it's not going to be a local. 0. Let's see how that works. No, I knew it. Okay, time to how do you global variables? I want to see global variables. Global. Okay. Because there are two types of variables in Squirrel: local variables. And I thought because global variables closure are stored in a table, they are table slots. Single identifier refers to a local variable. Tables. Global variables are stored in a table called a root table. But explicitly access the closure root of the function from another scope, prefixed with colon. Okay. What does that do? Let me see. Unique val does not exist. No. Yep. How do you declare them? This. Each function has a weak reference to a specific root table which can differ from the current VM root table. So function test foo is equivalent to write function test. If foo is in this dot foo, else foo. So I can do like this dot. Let me see. Raw set is like well. Okay, let me try that. Raw set, this is a function. Print this. This is a table. This log equals to 1. Raw set this log 1. This. Oh, constant too long. What? That works. What type of cursed language is this? This foo or so you can okay, you said that this is a table, right? So how do you append another value to a table? That's how. You can do this. Leak val 0. Done. Why? Maybe fakeObject should be. fakeObject. Let me see. Oh, damn. Now it works. It's probably crashing like at the end because it tries to clean up everything, but that's fine. Okay. So we just needed to put it as globals. That's what we need to do. So if we bring this back and try to run that leak plus offset. Yes, leak. Right, and then so if we try to do that, oh shit, I'm sorry. That's not what we need a lot more than that. Yeah. So now we'll see a lot of leaks, not just two. Make it 0. Leak at. Why it's so slow? One more time. No, that's bad. Oh, okay. Okay. I think I think it tries to free the other one because you. Yeah, that's what you. fakeObject. Oh, fakeObject. And take that to fake the no fake all fake outs. You do that, and then you add fake outs. Don't really need this. It's just to prevent frame the object when leaving our brain. Right? Now let's see it. No. Okay, let me see that. Continue, 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 continue. Oh, it works. We already leaked 2 times. Okay, now the 3rd time, that's where it fails. That's where it fails. Again, at release. But we are failing somewhere else. Operator. New slot. We're crashing like we're crashing here. Yeah, because new slot is that's not a good thing. Okay, I think I know what we can do. can we reference a variable? What is a weak reference? This weak reference allows the program to create references to objects without influencing the lifetime of the object itself. Perfect. That sounds exactly like what we need. The built-in method opt weakref. Weak references are first created through the built-in method opt.weakref. All types except not implement the weakref method. However, in both integers and floats, the method simply returns the object itself. When a weak reference is assigned to a container, it's treated differently than other objects. When a container slot how the weak reference is fetched, it always returns value. This allows the programmer to ignore the fact that the values handled is weak. When the object for a weak reference is destroyed, the weak reference is automatically set to null. Okay. So we can the lifetime of the object. Address, fakeObject. So that doesn't work because we crash at leaked value. Our breed. Let's clean that. Oh, you know what? Not now. We'll do this after. Have leak. So what happens when you meta methods? Maybe we can create a getter or something. Arbitrary read and then fakeObject. Come on, it works. It just needs to work more than once. Mm. Let me see. Maybe. Mm. Offset 0. Offset. Um, fakeObject. Oh, I think I know. Wait. You have leak val, and then you can fakeObject. And what if you just, I don't know, like write the address, read from the address. Read from the address, and then overwrite it again, but with something that is valid, like, I don't know, like local print address or whatever, right? And there won't be any issue to free that because this is a valid address of an SQ object. So that's fine. Or even better, make it like that. Let me see it. Oh shit, that's wrong. That does not exist. And address of, yes. Yeah, there's so many. And that's also what you need to do. Let's hope it will change something. Leak at 0 is this. And then it's gonna crash at the second time. Why? Well, fake objects, like, literally, that's not fair. That's not fair. Why? Why? That doesn't make any sense. Continue, continue, continue. Uh, I don't know. pString. You know what? Maybe we should get an OT table is this, right? A20 and OT string is, so let's just change it here. So instead of 10, we would write 20. And instead of A, we'll write, instead of 8, we'll write A. Let's see if it works now. Yeah, we are crashing. Why is that? T old type. Execute and set. Like next time we are writing here. Okay. Just out of curiosity, what will happen? Yeah, okay, that's still crashing. And Yeah, so we shouldn't maybe if we can do like out. Recraft. Create a recraft to the array and assign it to a table slot. Preferences. Find line prints because the only strong reference to the array owned by the local variable, so the following line assigns an integer a to the array. fakeObject. Maybe you don't need. Let me see that. Out. Leak. Well. Let me get back here. Look up. Let's see if that works. 0. The index recurve does not exist. Okay. What about that one? Okay, let me say leak is 0 and 0. 10. How do you define arrays? Ones. Right. Of the statement. Let's see, leak is 0. Okay. If you do this, now what happens? Okay. Cool. Cool. Fake out. Take out. And do this. So you don't have to get this globals anymore. You can just make a local and no, keep it. Let's leak val. and it's easy. Right. First, let's see if that works. It should work, but yes. No. Try it again. With 8. Now it's about to crash, which is not good. Okay. No. Okay. It's leak number 1. It fails. It fails. Okay. Let me see. One more idea. That's gonna be easy. So the out would be right. And then you take out. Because like you save a copy of that. Return leak val. Save a copy to prevent free. Error free. That makes sense. No. And then you do 1. And you say leak is. Okay. Now, where is out? That's out with ZZ. The index out doesn't exist. At line 64. Oh, that's because you need to. Line 106. The index leak does not exist. Because that's a local. Good. Now you have one leak. Let's try it again. Let's try it again with the same index. Let's try it with 2 indexes. It works. Okay. And we'll try another address that is a little bit more weird because this is the one that's causing our sec fault. Okay, that works. It's gonna crash, but at least we reached here. Yeah, let me see it one more time. Wait. 0x down. It's gonna be 3. No, come on. Don't do it. Why? Can you stop the garbage collector? Garbage. Come on, what? Why? I fucking hate my internet connection. Okay. Memory management. Built-in functions. Collect garbage. I want the opposite of that. Finds the garbage collector and returns the number of references. Detection. Okay, I don't want new thread, version, size, float size. Delegate, containing a self function to manipulate. Resurrect unreachable. API only work. Okay, is that defined in the default? We see and no garbage collector. Yeah, it's just the docs that we just read here. 2006 said improved C reference performance and no garbage collector builds. But what if I... Oh god. Runs the garbage collector and pushes an array in the stack containing all unreachable objects. Just don't free it. What's so difficult? Why is that even an issue? You know? Leak val, so... maybe fakeObject is this. Mm-hmm. Just don't do anything with this. Well, I think this will work. Cool. Very nice. Okay. I understand now. I understand. Okay, so let's see it. Let's do this. And then run the loop. It gives us a lot of leaks. And make that array like a lot of indexes. Right? Just enough to run this loop, which runs like 20 times. Yeah, if I calculated it correctly, because we're adding 0x 0x8 on every iteration. And is this. Just lol, and then oh, you know what? I'm sorry. I feel stupid. Of times 8. That's what we need to do. And of is plus 1. Yeah, 16. Out. I think it's possible for tables. Print 1, 2, 3. Then. Yes, it works. Okay, so and then off, and then this is offset plus offset times 8, and yeah, I'm stupid. I'm sorry. Offset. That's going to be IDX. And that's also going to be offset. Leaked plus offset is, then we print the leak. Right, so we are filling this array with a lot of leaks. And then we print them. Now it's the moment of truth. Let's see. No, that's almost. That was weird. 132. It's IDX plus times 8. Wrong number of parameters. 132. Print IDX. That's going to be ZZ. And then I think it's fine. Maybe it's just unlucky. Try it one more time. Okay. 132. Leak offset is okay, let's try that. Now let's see. Okay, that's fucked up. That's weird. That's very weird. Error has occurred. Wrong number of parameters. Call stack. Function 132. Yeah, it's here. I think it's here. So you have ZZ. And you add it to out. ZZ len. Print address plus offset. Final address. Print address. Oh, what? Oh, I have a typo. Print address. Yes, you have it here. Okay. Okay. So you can leak print. And every time you add another 8 and another 8 and another 8. And 932. Yes. That's what? Final address.
Whoop. Here I come. Oh, here I come.
Yes. Now it works. What? Oh my god. That looks so good. This is like raw memory. Beautiful. Beautiful. Let me see. Yeah. Pointer. Let me see the... Yes. Another pointer. Another pointer. Oh, guys. Finally. So, the issue was that, I don't know why, but every time we are doing like an addition operation, like here, literally 1 second before we are calling this, like while we are putting the arguments, we are executing a plus operation. For some reason, it causes a seg fault. I don't know, maybe the language is broken or some shit. So what I did is just, instead of putting the plus here, I just added it to another variable, and then after it's inside a variable, we provide it here. So yeah. I am very happy right now. So we are done with this. And are we gonna continue now? I don't know. I need a break. I need a break to think about this. If I'm going to do the right primitive today. But yeah. Overall, this is very good. And I guess that's it for now. It's 9:30 p.m. right now, so I still have time. Like, if I take a break, maybe I can come back later. Or worst case scenario, I could do this, like, I could continue tomorrow morning because it's holiday now. We have a Jewish holiday. It's called Sukkot. So tomorrow I have a vacation. I have like a day off from work. Anyway, I think I'll just go to eat now. Thank you for watching. I hope it was informational or whatever. And I see you in the next time when we work on the right primitive, on the arbitrary right primitive.